So good morning, everyone. So today we have our third day of FTP on earthquake engineering, and this program, as you know, that is sponsored by Atal Academy AICTE, and it is organized by Marwadi Education Foundation. Today, in first session, we have Dr. Ajay Chourasia with us. Sir is currently working as a principal scientist and the group leader of 3D concrete printing group at CSIR Central Building Research Institute, Roorkee. He did his PhD in structural engineering from IIT Roorkee on performance evaluation of confined masonry building under cyclic lateral loads. His research interests include precast building, structural health monitoring, confined masonry, seismic vulnerability assessment, post-earthquake damage assessment, repair and retrofitting, and earthquake resistant design. Sir has published more than 100 research papers in various reputed international as well as national journals and conferences, and Sir has also filed 4 Indian patents. This is what is the gray area for Indian scientists, and Sir has made the remarkable contribution in filing patent also, so it's really appreciable. Sir has guided 5 PhD theses, 30 MTech dissertations, and 60 BTech projects. So Sir has shown his intention to have to be with the academics since from long time. So it's good that the scientists, they are in the field of supporting academics also. So sir, at this juncture we welcome you all. Thank you very much for accepting us our invitation and sparing your time for this knowledge sharing session. So thank you once again, and sir, I hand over the session to you now.
Thank you, Dr. Sir. I'll share this. Yeah. Sir, is my screen visible?
Yes.
And audible also properly?
Yes, sir.
Perfect.
Yes, it's visible and audible.
Okay. Thank you so much. So, can you are you giving me permission to present?
Sure, sir.
It's our pleasure, sir. With pleasure. Please carry on.
Thank you so much. Namaskar. Good morning, everyone. And first of all, it is my pleasant duty to be with us, with you all, and share some of the experiences on a very pertinent topic. So before coming to the topic, I would like to sincerely and honestly thank Dr. Ankur and Dr. Tarak and entire management of Marwadi Education Foundation for inviting me and giving me an opportunity to talk on a very pertinent subjects of today's scenario, on that is on simplified and detailed vulnerability assessment of buildings and seismic retrofit strategies. And my emphasis will be basically focusing on the lifeline buildings first, because as you are aware that at the moment we are passing through a crisis, not we, entire globe, and we learned a lot throughout this pandemic. Apart from that pandemic, we have also understood the importance of different lifeline buildings, hospital buildings and school buildings in particular, because hospital buildings are immediately required after any kind of pandemic or disaster. Similarly, the school buildings can also be occupied as a emergency shelter, relief center, to provide the immediate needs of the people of India. So keeping in mind, as again, I would like to emphasize that our country is very large. We are suffering from a very large number of problems. Housing is one of the problems. Buildings, resiliency of the buildings is another big issue. we have large number of building stocks at one point of time. Most of the building stocks is masonry buildings. It is well known by now, whatever lectures you have heard, that masonry buildings are highly vulnerable, particularly in case of earthquakes. And we have to take a call that we should uh, make them seismic resilient, if not, so that whenever next earthquake strikes, it can become a hazard, but not a, or it can become a disaster, but not a tragedy. So for that purpose, if we look at the numbers in our country, around 85% of existing building stocks, that is almost 150 million buildings, are masonry buildings, and only 5% buildings are reinforced concrete buildings. Unfortunately, we all are paying a lot of attention on this such RCC buildings, but yes, it is required, but at the same time we cannot ignore masonry buildings, and rest of the 5% buildings are uh, classified under traditional building constructions and technologies. So all such buildings, most of the buildings are suffering from some kind of the other non-compliance of codal provisions, and as a result, we may lead to another kind of a disaster or tragedy. And whenever we look at the philosophy of earthquake engineering, which clearly tells about the immediate occupancy or life safety is first, but because we should not compromise, or we don't want any loss of life to occur. Then the collapse prevention, that collapse of the building should not occur. Now, with the advancement of the time, there is a slight shift in philosophical thinking of earthquake resistant design. That is, from now it has been further extended from life safety and collapse prevention to the immediate, reduce the immediate property losses, reduce the business losses, time losses during relief operations. So with such a large expectation, aspirations from the people of the country, from the engineering community, it is high time that we should tighten our belt, prepare ourselves, create awareness, and go ahead with this seismic resilient construction by conducting building safety audit. Again, I would like to encourage you that please don't try to pinpoint the mistakes of others. Rather, start doing good things from of your own, because charity begins at home. So that's why let us start. If everybody contributes a good job towards this engineering compliance or engineering aspirations, I think entire change we can bring in our country. So with this small background, I would like to finish. I would like to begin my journey on this particular topic. And whenever we are talking or considering about any hazard, earthquake, landslide, or cyclones, natural or biological or whatever kind of, we are associated with the risk. And whenever you are associated with the risk, don't be run away from the risk. Don't get yourself disheartened. Rather, you should take risk as a challenge, take it as an opportunity, try to learn more and more from the risk. Because risk, a very typical or very peculiar interesting dialogue is there. Risk hai to ishq hai. I don't know whether you understand my Hindi or not, but risk hai to ishq hai. Ishq means ishq, love with your, and love and passion with your profession. So if you develop that, I think we can move ahead in a great spirit. And whenever we are talking about the risk, which is basically a function of hazard, exposure, vulnerability, and location, that again varies from place to place, because our country, which has now been classified from seismic consideration 4 seismic zones. So basically, hazard, we cannot stop. Occurrence of an earthquake of sufficient magnitude, which is capable of causing any kind of a damage, man-made or natural, is there. So we have to be ready and prepared to face such kind of a consequences. On the contrary, exposure is important aspect which is for which engineer as well as the administrative or local bodies are responsible. What exactly exposure means? The objects and structures built by the man or engineers in particular, which are exposed to the effect of hazard, that is bridges, buildings, lifeline structures, so on and so forth. So they should be made more resilient in compliance at least with the codal provisions which are prevalent in our country. So at least we can reduce a risk to a large extent. So hazard we cannot control, risk exposure we can control by good engineering, design, planning, execution, maintenance, and practices. Whereas when you talk about the vulnerability, which is basically nothing but the exposure under action of hazard, in that what will happen, the weaker one will suffer, stronger one will enjoy. So that is what will be happening, and for that purpose when we look at in our country, most of the existing building stocks is falling under this category. So again, engineers are responsible. We have to take a call. Slowly we have to reduce our vulnerable building stocks database for the country. When you talk about the location, this is also one of the important parameter as a which is associated with the risk. That is how far the exposure is situated from the hazard location, the near ones being greater in danger than the farther one, and for that purpose, even you are located on the farther end, but still you might be affected too much. That again depends upon not only the distance but also on the geological, geotechnical scenario which is existing just where you are founding your building, and in that path, that is from wherever the earthquake is originated from, that is basically origin and path. That also contributes a lot apart from the distance. So again, location I cannot help, hazard I cannot help, but as an engineer, it is my prime duty to try to reduce the exposure and vulnerability to functions which is associated with the risk. So as I mentioned earlier also, the engineer is not only an engineer or technocrat. He has to play or he has to act in different verticals. Like he's like a film actor. He has to work, he has to play a role of social, economical, political, scientific, and technical activities. All of these aspects contribute to overall goal of earthquake engineering to prevent earthquakes from becoming disaster. So with this philosophical shift, if we look at our understanding on the earthquake engineering, for that purpose, we may have to refer mostly on the ASTM 41, ATC 41, 2013. So in that, if we look at, so it is basically, if we talk about building audit of any infrastructure, then it is basically we have to define the performance objective. What is your expectation? Whether you want your infrastructure to be operational immediately after the disaster, that is fully operational, or operational, that is particularly very important in case of hospitals, fire stations, important office buildings, from where the control of post-disaster mitigation is to be done. In addition to that, the school buildings and assembly halls, wherever you are accommodating more than 250 persons at one store. Whereas we cannot afford to construct all the buildings from cost consideration, with keeping in view the high importance factor or high zone factor, and for that purpose we will allow our code permits to allow the building to go under large deformation to sustain certain of cracks, damages in the buildings, and those cracks should be such that they can be repairable at a minimal cost, but collapse should not occur. So that life safety is another important parameters which is associated as a performance objective, and it is mostly applicable for all kinds of ordinary buildings, residential buildings. Definitely, we don't allow the collapse to occur. Our code doesn't allow, so we don't want that our building should collapse. So for that purpose, again and again, I'm telling that the compliance to the Indian codes or to the provisions given in the seismic resistant codal provisions should be honored. And when you, on the contrary, when you see the return period or frequency of earthquake which is happening at different point of time at particular location, so that has again be assimilated as frequent earthquake, occasional earthquake, rare earthquakes, and very rare earthquakes, depending on the sequence of operations. Means it is, there is a possibility a great earthquake might occur at one particular location after a span of 2,475 years. But we cannot wait for 2,475 years. So for that purpose, normally we consider our building life as 80 to 100 years. So we are focusing to 72 years or 475 years. And as a result, we are making certain compromises in our design procedures, allowing building to damage. And take it from me that when you look at really the design of, we are not designing to the fullest occurrence of earthquake, critical earthquake. Whereas there are so many factors which has been introduced in our design procedures and which reduces the design impact level of earthquake to a large extent. So frankly speaking, we are designing as of now our buildings only 1/10 to 10 to 15% to the to that of the expected earthquake which may occur in at given point of time. So with this backup, there is now a great expectation from the society, and we have to make our, at least not entire country seismic resilient, but we have to move ahead with step by step. And for that purpose, at least we should start this particular work from our campus, in our town, in our district, then to the state, and then for the country. And to begin with, again, this Herculean task, to let us begin with at least with the lifeline buildings, that is hospital buildings and school buildings and educational institutions. So what exactly this what we exactly mean by the design performance objectives? Basically, it allows you that under a small shaking, only minor cracks are permitted, or no cracks or non-structural members may damage, but there is no damage for a structural or non-structural member. In case that is a possibility most of the times in the case of a rare earthquakes which may occur in a span of 43 years of low magnitude or low. In the case of a moderate earthquakes, we are allowing our structural system, basically non-structural member, to go under damage, which can be repaired, and slight minor damage to the structural system, particularly to the beams, not to the columns. But in a large or great earthquakes, we allow our building to damage the non-structural members as well as few structural members, but collapse should not occur. So this is what basically is generated in terms of a base shear and roof displacement. So when you talk about the disaster, now we have to talk about the disaster risk reduction 2015. There is a framework which was set by SENEDI, which is called as a SENEDI framework, which is applicable from 2015 to 2030, which also focuses to strengthen our important lifeline buildings first. And strengthening doesn't include simply the structural members, but non-structural members also, and critical facilities. At the same time, we should inculcate awareness that all the new structures should comply with the codal provisions, but at the same time, we should take care about the existing facility to make it seismic resilient. And during this survey, we should identify the critical facility which are located at inaccessible region. For example, a hospital is located at such a location, in a very crowded location, and in case it may so happen after the disaster, collapse of building may take place, and there is no access to the hospital. In that case, this kind of a facility is of no use. So your critical lifeline facility should be located accessible in such a location that it should be accessible after the disasters. So this consideration need to be given and focused as a background, and this we should not see only from the point of structural damage, but also from the non-structural damage, non-structural elements. There are a lot of non-structural elements which are posing falling hazard and keeping the occupants on a vulnerable situation, causing most of the times injuries and loss of life also. For example, in case of a hospitals, when you come across, so after the earthquake, if you get this kind of a scenario in a hospital, then even if your building is made enormous amount of seismic resiliency in the building, it is of no use. That means we have to take care about the non-structural members like gas pipelines, false ceilings, cylinders, whatever the almirah and other things should be anchored properly, tied properly, furnitures and all these structural and non-structural members. You can see in this particular slide that the green color indicates the structural members, and whereas the red and black color indicates the non-structural members. So such even your infill masonry walls in RCC frame buildings is a non-structural member. So such member should be adequately connected, tied, and must be robust adequately, so that in case of a shaking, they should not create a falling hazard. And when you look at the structural system, yes, we have 4 structural system typologies. That is the RCC moment resisting frame with braces and shear wall, and typically our traditional masonry buildings are always there. So when you talk about the earthquake resiliency, India is not behind to any of the when it is compared to any developed country in terms of knowledge, codal provisions, guidelines. There is ample codal provisions and guidelines which are available, and they are being revised from time to time. And with the recent one from seismic vulnerability assessment and retrofitting consideration is IS 13935/2009, and seismic evaluation and strengthening, which is more pertinent to the topic of present discussion, is IS 15988, which takes care how to evaluate this, your building infrastructure, and if it is found deficient, then what are the way out to strengthen it, retrofit it. So codal provisions are there, and for that purpose we need to start our journey to assess the seismic vulnerability of the buildings, structural, non-structural. Whenever you are looking from the structural consideration, first of all, have a look under which type of that has to be done under 4 categories. That is what building typology, history, architectural shape, and design and execution. In the typology, you have to understand first of all which type of building typology is there, whether it is a load-bearing structure, RCC frame building, steel structure, and what type of foundation and other structural consideration. Apart from that, the history is also important, because aging also kills the building or its intended purpose. So aging, change in use, change in past, design at the time of design, what kind of loading you have taken, this need to be understood from the prevalent building, which is for which you are conducting the building structural audit or damage vulnerability assessment. Definitely, you must have by now understood well about the planning of any building. In terms of plan, it should be symmetrical and irregular in plan in both in horizontal and vertical directions. So, and a connection should be adequate, and design should have been done adequately. So these aspects will be addressed under the structural seismic vulnerability category, whereas the non-structural systems or non-structural vulnerability and content vulnerability should also need to be understood, and from the point of view how the non-structural elements like false ceiling furniture, roof tiles, rooftops, tanks have been anchored, placed properly, and they are not, if they are having excessive mass, they should not create unnecessarily the excessive torsion in your building. So all these things need to be understood in the non-structural assessment. So whenever you talk about the vulnerability of a building, that may occur at different stages, different point of time, particularly at the planning and design stage. It might be possible you might have designed your building and constructed your building as per the prevalent Indian standards in 1982. But when you assess that same design or same building as on date, it may be deficient because there is a continuous increase in the seismic provisions, seismic codal demand, and as a result, that building, even your design at that point of is safe or correct, it may not comply to the today's provision. Apart from that, their side, we make use of a softwares blindly without understanding what is happening at the back box, and that's where we are not able to design our building properly. Please I apologize to the youngsters, but I will at the same time I salute the seniors. In old days, we used to do all the designs and manually, one by one, although it was taking a lot of time, but that was giving us a confidence that yes, whatever I did is correct. But in case of when we are using the softwares, it is not happening. So that's why make it a habit. Whenever you are designing any structure, try to check or cross-check by your manual hand calculations as well. Because a small 1% or 5% error may lead to a 50% error in actual performance. So this is very important. Changing the standards and architectural planning design is important. Most of the times we ignore to conduct the geotechnical investigations. Most of the we conduct certain assumptions, consider certain assumptions for designing our foundations, and that may lead to some kind of settlements. And these are the basically reasons which are putting our buildings into trouble, vulnerable. Most of the times you are constructing your buildings on a sloping area, hilly region, and as a there you don't have a flat land, and at that point of time you have to go for construction on a sloping ground. So at that time you have to take extra cautions on avoiding short columns, providing adequate buttresses, stiffness in your columns, and plan your buildings properly. So uniform strength and stiffness distribution along the height of the building is very, very important whenever you are dealing with the design of buildings in sloping region. At the same time, ponding is also one of the important parameter which is creating trouble to all the existing buildings. We have an habit not to leave the setbacks. We are trying to construct every building very close to each other, and what happens during the shaking, the building shakes and it may collide with each other. It may cause the hammering effect on the adjoining building, and then again the taller buildings transfers its forces on the lower building, and because of ponding effect, even if your building is earthquake resistant, but adjoining building kills your building. So that is the problem. So please give adequate separation gap between the two buildings, and those gaps, how to calculate that has been clearly spelled out in our codes. I'm just taking a 1 minute pause just to interact with you all. Am I going too fast or too slow, or is something I need to correct myself? Please give me your input.
No, sir. Pace is okay. Yeah.
Okay, thank you. Then another reason of the vulnerability is execution. During the execution, we may be defective or construction procedures or poor detailing poor construction practices, maintenance, and existing defects, particularly the corrosion and other things, they are creating trouble to the service life of the building, and that also is very important from construction execution as well as maintenance consideration. So there are various wide range of codes available, and one can refer these codes while design executions or at the time of audit of the building. Apart from that, when you are our codes have not been upgraded so far for the critical or lifeline buildings. For that purpose, NDMA guidelines may be referred to, that is for the hospital buildings and for the retrofitting of the buildings. So this is very important references one has to make while conducting building audit. Apart from that, international code, that is ASC 41-2013, is also very important when you are conducting performance-based analysis of existing buildings. Particularly, we conduct the linear static analysis for the masonry buildings and the non-linear time strip, in particular, analysis for the RCC or steel structures. So these are the codal recommendations, guidelines emerged out from the NDMA with respect to lifeline buildings, that is particularly the hospital buildings, and which clearly tells the performance objectives of such buildings and other critical units. When you talk about the building vulnerability methodology, then generally the assessment, building vulnerability assessment is categorized in 3 levels. Those are rapid visual screening, simplified vulnerability assessment, and detailed vulnerability assessment. See, rapid visual screening is normally being done when you have a large number of building stocks. You need to do, so this is basically, name itself suggests it is a rapid process, just done visual basis, and it is a very qualitative. It doesn't give you, ensure or clearly defines whether your building is safe or unsafe. It will just qualitatively indicate whether your building is unsafe or safe, and whether you have to go ahead for the further detailed investigations or not. So I will not go much into detail. It's a very simple process. So now coming down to the simplified vulnerability assessment. So this is a basically very important aspect in that in this particular assessment procedure, whenever you have been given a task to conduct the building audit or building vulnerability assessment of any building, you have to follow the following steps, irrespective of the building typology. First of all, condition assessment and visual survey of the existing building is very, very important. And based on that, you have to again collect the structural drawings, architectural drawings of the existing buildings. And 99% cases, you will not find those things. So don't get afraid. It is a common story everywhere. So your responsibility job increases. You need to prepare your drawings, as-built drawings. And for that purpose, apart from the architectural, structural also. So for that structural things, apart from the geometry, you need to find out how the detailing of the reinforcement has been done, what is the condition of the reinforcement, what is the size and spacing of the reinforcement, and that you can do by conducting a rebar locator, by using rebar locator tests. So you have to recreate the structural drawings. So after conducting these 2 tests under the seismic vulnerability assessment, you don't need to go into much detail about the non-destructive test to assess the in situ compressive or material strength. In that case, by your visual observations, you can assume certain material strength and parameters, and you can proceed. But definitely, yes, when you are conducting a detailed vulnerability assessment, you have to conduct extensive non-destructive tests, particularly the rebound hammer, concrete core test, UPV, and rebar locator, and all the important parameters, whatever data you are generating from the extensive non-destructive test, has to be taken care, uh, and the results are to be incorporated in your structural analysis, detailed structural analysis. And for that purpose, and normally we carry out the structural analysis now in the 3D mode. There are numerous amount of softwares are available, and generally we conduct the linear static analysis for the masonry buildings, whereas non-linear time history or response spectra analysis for the RCC frame structures. Then after conducting the analysis or beforehand also, one has to carry out different checks as given in table 5 and table 6 of IS 1893-2016. That table 5 and 6 tells about the configuration related checks on plan and vertical irregularity, geometrical checks in terms of the maximum allowable clear heights, then the drift, deformability, lateral strength, stiffness, mass distribution, and also the strength related checks related to the shear, axial, and drift. So all these checks in compliance to the table 5 and table 6 of IS 1893-2016, one has to conduct, whether it is a masonry buildings or load bearing building, RCC frame building. So when you are not, so this is an example how you have to create and recreate the drawings. So first of all, you need to create the site plan, then take the help of a Google, locate your buildings, because whatever report you will generate during your building audit will be referred to someone, and nobody should put a question on in front of you to give. So to address this, you give proper references and references, and for that purpose, take a Google map, put the location of the buildings, locate your site, and draw different plan elevation, and with all detailing the way you draw for the new buildings. In fact, sectional elevations and connection details are also very much important. In addition to that, you have to display or connect the visual photographs which you have collected to give the more clarity for different detailing which has been done. So this is one of the attempt we have done. So I'm sharing with you. So apart from that, before conducting the detailed non-destructive assessment, during the visual assessment, you should carry out extensive amount of the distress mapping. That is, assess each and every element, find out what kind of a distress is there, whether it is suffering certain crack, what is the width of the crack, length of the crack, what is the size and shape of the crack, and categorize in a specific, in a proper format in a tabular form, and define it, the reasons, if possible, thereof. So that is how the distresses which have occurred in the building are documented properly with observations and pictures, and can be taken care in while executing your numerical analysis. Generally, this is the data which this is the format which has to be adopted for collection of the data, that is, which includes the general detail, the architectural data, structural and non-structural data, equipment data, so on and so forth. After collecting the basic information about the data, about the geometry, about the material property, one has to now move on to the office and carry out the numerical analysis or numerical modeling of the existing building. Normally, one has to carry out the 3D modeling nowadays. Now the ETABS, TAD, and any software you can make use of in which you have mastery in conducting such analysis. While conducting the analysis, masonry walls should be modeled as a shell elements, 2D elements, whereas the material properties can be obtained from the non-destructive test. In case of a masonry, it is very important that how you can pick it up for the material property. The generally conducted non-destructive test defines the material property only for the concrete, but in case of a load bearing structures, masonry is involved, so in situ material strength is very important, and for that purpose you have to conduct the flat jack test also to know the in situ material strength. If you do not have access to the flat jack apparatus or equipment, then alternatively one can do one can take the certain specimen samples of the bricks, mortar, assess its in situ compressive strength, and based on the in situ compressive strength of the bricks and mortar, you can refer to IS 1893 2016. Uh, there is a provision to calculate the in situ compressive strength of the uh, masonry based on the brick and mortar strength, as well as you can calculate the modulus of elasticity of the masonry based on the this in situ uh, masonry strength, which is 550 times 5 em is equals to 550 into fm. So this is how you can converge to the input parameters which need to be essentially required to be given for the for any kind of analysis, that is material properties, density, Poisson's ratio, then compressive strength and E values. When you are dealing with the RCC frame building or otherwise for masonry buildings also slabs and beams. So for that purpose, you can model the beam as a line element, 1D element, slab as a again membrane, 2D element, conduct the non-destructive test on this RC element and take the data and use as an input to your model. Definitely the loads, after doing the material and geometrical properties input parameters, loads, dead load, live loads, earthquake loads and other combination thereof can be taken as per the provisions given in different codes as listed in item 6C here. This is the example in which we have conducted modeling of a load bearing structure. First of all, by adopting the procedure as I have explained you just now. And after conducting this modeling, parallelly we can conduct the configuration related checks as per table 5 in terms of torsion, re-entrant corner, floor slab, cutouts, out of plane offsets in vertical plane, non-structural, non-parallel lateral forces. As regards to the understand the vertical irregularity, table 6 of clause 7.1 of 1893/2016 can be referred, which clearly defines about the stiffness, mass, vertical geometry, in plane discontinuity, strength irregularity, floating or stuck column treatment, and irregular modes of oscillation. So these all criteria provisions which are given are to be adopted as per table 6 in your and to be checked for the model you are performing the checks. Particularly for the RCC frame structures, the geometrical related checks in terms of column width, column size, aspect ratio, partition, all these things need to be adopted or taken care as per the detailing given in IS 1392/2016. So after conducting the such kind of a checks for the masonry buildings, particularly the shear stress checks for the unreinforced masonry shear walls as per IS 15988 and has to be done. The permissible values of the stresses for the masonry buildings can be obtained or derived from IS 1905. For the axial stress deficiency, approximate column shear stress, IS 15988 can be referred. Story drift limitations as 0.004 story height can be taken from IS 1893, and the strong column weak or adequate beam phenomena can be checked, and along with the different retrofit strategy can be checked from can be referred from the IS 15988. Once you have conducted the seismic vulnerability assessment, you will come to the conclusion in which you have not done extensive entity. You will come to the conclusion that whether your building is safe or not. How you will come to know? You have to check all the entire building at a global level as well as at the local level, element level, whether any of the member is deficient or not, whether all the entire building is meeting the provisions made in the code. If not, then identify the deficient members and try to strengthen such buildings, uh, such elements, so that you can after identification of such deficient element, you can plan what is the appropriate retrofit strategy to be adopted to make that particular unsafe or deficient member to a safe category. And when upon doing so, again, you have to incorporate that retrofit strategy into that deficient member. Again, redo this particular exercise and carry out all the checks. So whatever I have explained by now for the masonry buildings is explained here in the flow sheet. So create a model, conduct the detailed material and geometric checks, perform the linear static analysis, extract the stress and drift requirement parameters from the analysis, then check the different codal provisions. If passing, fine, go for the DPR. If not passing, then again strengthen it, retrofit it, and redo the analysis. This loop has to be repeated till your building is made safe globally as well as locally. Similar like exercise one has to perform for conducting the detailed vulnerability assessment uh, for the RCC frame structures also, but instead of performing the linear static analysis, one has to perform the non-linear dynamic analysis, and for that purpose you have to follow the same procedure. In this case, you have to make a reference not only to 1893-2016, but also to IS 13920 to conduct the geometry related checks, size and shape related checks. And while conducting the non-linear dynamic analysis, one has to conduct the time history analysis, and for that purpose, you have to pick up minimum 3 time history of the earthquake which is expected in that particular region. If and those time history analysis should have adequate 3 component, 2 horizontal and vertical component, and having a time period ranging from 0.2 seconds to 1.5 seconds. So wide range of time history one has to select. You have to be very particular while selecting the time history. It should comply with within the period of the building which is to be analyzed. Apart from that, the geological and geotechnical characteristics need to be understood, and you have to pick up the time histories wherein the earthquake has occurred in the similar region or not. If such time histories are not available with you, in that case you can rely upon, or you can take a rescue from the simulated or simulated time histories also. To create while conducting the nonlinear dynamic analysis, one has to assign hinge properties in your model, and for that purpose one has to take a reference to the ASC 41 2013 for taking appropriate ratios of P M2 M3 for columns and M3 for beams, and perform the nonlinear time history analysis as I have mentioned, and repeat the process of checks and cross checks. And once it has been done properly, then if you are using suppose ETABS, then you have to take the support reactions, take those reactions to the safe software, and then carry out your verification or checking of your foundations also. So in after conducting the simplified vulnerability assessment, we come to know that whether my building is safe or not. It gives me a primitive idea and very fast procedure also, but relatively time consuming when you are comparing with RVS level 1. But little bit it is addressing your quantitative requirements. But to even if while after conducting the SVA, if you are coming across that your building is unsafe, it is better practice that one should conduct a detailed vulnerability assessment by conducting the detailed in situ material investigation. So entire process as adopted in the previous one is same in the DVA. Only thing, extensive amount of site assessment you need to do, and the data quantitatively collected thereby has to be implemented in your model, and then conduct all the checks as mentioned earlier. So basically, DVA requirement component obtain the existing material properties of masonry and RCC through entities, obtain the soil properties. You cannot carry out your analysis, DVA analysis in particular based on assumptions. So if not available, conduct your soil investigation in detail, the way you have to do for the new structures. Then based on that, you have to verify the condition of foundation or design of your foundations. Then decide the performance levels and retrofit options based on the functional purpose, intended purpose of the building. Carry out the modeling and analysis and perform the different checks and acceptance criteria as per the code and guidelines. The procedure is the same as I have mentioned earlier. Only thing is you have to conduct this entity and the soil investigation, whatever I have been discussing by now, has to be taken care of. For while dealing with the masonry buildings, one has to take the help of IS 4326/2013 as well as IS 1905 for assessing the different seismic resilient provisions, measures, both in horizontal and vertical perspective, as well as IS 1905 for permissible stresses of masonry. So this is one of the example I'm showing. So from wherever you are taking the, while conducting the entity, from wherever you are taking the samples, please mark appropriately, correctly on the drawings, because if someone wants to verify or cross-verify later, it will be a very useful document what you generate. Again, I was simply saying the foundation verifications, foundation checks, so on and so forth, but it is very not, it is the way simplistically I was mentioning, but it is very difficult to conduct at site. Foundation strengthening is again a very Herculean task as compared with the superstructure, and again for getting the information on the foundation is again very, very difficult. So for that purpose, one has to randomly take a call on the site on the basis of site observations, carry out the certain trial pits at the and expose the foundation, find out its site shape, if required, carry out certain removal of the concrete, chip out the concrete, find out the how the reinforcement detailing has been done in the foundation, or alternatively you can make use of a rebar locator to assess how the size, shape, and reinforcement detailing. This is the slide which shows the detailed investigation one has to take for masonry buildings. This is the test setup for the flat jack, which will give you the in situ compressive strength of the masonry. Alternatively, if you are not having flat jack, not an issue, you can take certain samples of the bricks and mortar separately, find out their in situ compressive strength and other properties, and these properties can be incorporated in the formulations given in IS 1893/2016, and thereby you can calculate the modulus of elasticity of the masonry as well as the masonry strength. So other pictures shows the concrete test which has been done for the core cutting, UPV, ultrasound, rebar locators, rebound hammer, and so on and so forth. So this is the example how the trial pit has to be made at the site, and this is another example which shows in case of any difficulty, please conduct the detailed soil investigation at the site. And after doing this exercise, draw the pictures, draw the figures, uh, uh, showing the detailing of the your observations about the what has been implemented at site. Upon doing so, now you have identified the deficient members which exist in your building, and now it is a time to think of retrofit. And for the retrofitting purpose, one has to find out alternative ways and means. So there are plethora of techniques available for retrofitting for masonry, of steel plate, widely used steel plate jacketing or welded wire mesh or FRP wrapping, or sometimes providing additional reinforcement along which is embedded within the simple cement mortar plaster or shotcrete is widely used technique adopted for strengthening of the masonry building. I am sure that in the subsequent lectures it will be taken in detail. I am not going in much detail about the strengthening aspect at this point of time. As regards to the other techniques which is basically widely used, that is the fiber reinforced plastics. RCC in this, either the FRP laminates can be applied as in lieu of your RCC band if not available in your building, in particularly for the masonry buildings, the way it is shown in this particular picture. Similarly, the FRP laminates can be adopted for strengthening your slabs. Again, it has not to be done on the prescriptive basis, but it will depend upon the detailed analysis what you have carried out, in which you have carried out the detailed modeling. The model structure was imposed to extensive amount of demand which has been placed on the structure, and thereby you have computed the capacity, and if your demand capacity ratio is not adequate, in that case you are taking a call on strengthening of that particular member. So basically depending upon the deficiency, one has to decide appropriately what kind of technology you need to apply. While adopting any kind of a retrofit technology, one has to be very careful in selection of appropriate method based on the site conditions, time window available with you for the retrofit, cost aspects, local competency of the contractor, and the user's comfort in particular. That is, these are the important parameters you have to use. And whenever you conduct such kind of a retrofit, take a call that it should be done under a strict supervision of the experienced, knowledgeable people. Ordinary contractor cannot do it, and you should not get it done it also from him. And so these are some of the tips one has to be very particular in while conducting the retrofit. And while doing retrofit, again, one has to take important things as preparation of the surface is very important. So basically, preparation of the surface, and whenever you are implementing any additives, expensive additives, that doesn't make your structure safe, but the way you make the composition of those additives, the way you apply is more important. So simple investment is not important, but the procedure and implementation is also very important. So you have to be very particular on that. These are some of the techniques which are normally dealt for the masonry buildings. That is the sandwiching with hard drawn wire mesh, as I have mentioned, or stainless steel mesh. Sometimes the lightweight FRP or GFRP complete fabricated textile sheets are applied, if not laminates. So, but when you see this kind of different techniques, most of the time in RCC buildings, 50% of work now is being done using in terms of retrofitting is done by making use of FRP wrapping. But please be careful whenever you are conducting any FRP wrapping. It should be done after detailed diligence, after detailed engineering, calculation, computation, and it should not be done based simply on the prescriptive basis. So, and a subsequent speaker will definitely highlight more into detail, but my job is to tell you the After selection of appropriate retrofit technology, simply recommendations in text form will not serve purpose. Engineer will understand only the drawings. Whatever recommendations you make, prepare a clear-cut, detailed engineering drawing with all specifications and methodologies given therein, and the locations where you need to retrofit. So this is the one of the drawing I'm sharing with you, in which a masonry building is to be retrofitted in by means of a welded wire mesh band as a bandage technique. And in addition to that, the corners need to be anchored properly. Two perpendicular walls need to be connected properly, and how to connect it, so that we have recommended that additional reinforcement has to be provided at the corners in the form of an angle, and the connection between those two angles and embedment is detailed in detail in the drawing. Your drawing should be a very micro level detailing should have been there. In this picture, you can see the welded wire mesh which we have adopted in the present case is of size 35 mm by 35 mm by 3.2 mm GI welded wire mesh, having a width of 450 mm. This was anchored to the masonry walls by means of a nails, but it is not a nail, it is a stapler. So which is staple, basically it is not a nail, it is similar to the nail, but it is a U-shape anchorage, and both the ends are sharp, and you have to simply nail it, provide the impact and anchor it into the existing masonry. Whenever you are putting such staples to anchor your welded wire mesh or reinforcement to the existing wall, please carry out the preparation of surface, then nail this, provide this staples in a random fashion, not in a straight line, and it should not be distancing far away. Maximum distance permitted is 450 mm, 1.5 feet, and it should be staggered the way I have shown in this particular picture. Detailed experimental evaluation also shows the nailing density, how much you need. Minimum 9 nails or 9 staples per square meter need to be provided with adequate spacing, with adequate fashion of its positioning is very, very important, particularly at the corners. Whenever you are applying such kind of a welded wire mesh, it should not be lapped or overlapped at the corners. It should be overlapped at a distance of one third to the away from the corner, or minimum h/6. H is the height of the building, h/6 away from the corners of the wall of the room. This is an example wherein we are strengthening entire wall using welded wire mesh. So again, the methodology, procedure, precautions, whatever I explained in the previous slide is applicable here as well. Then you need to strengthen the foundation. So foundation strengthening means most of the times you have to enlarge the foundation size. And in that case, widely used approach is either to drill the hole in the masonry and then clean the surface, provide the additional reinforcement, grout in that particular thing, and protrude the additional reinforcement which was embedded with outside, and carry out the additional masonry work. If it is a masonry strip footing, if it is a RCC footing, then you can carry or sometimes even if it is a masonry building, you can provide a RCC beam kind of element having a width equivalent to the size which you want to, by which you want to increase the size of footing. So addition of masonry or concrete can be made to the existing footing, but be careful the adequate connection tying of new masonry or RCC with the existing masonry by making use of a shear connectors need to be ensured adequately, the way it has been detailed in this particular slide. As I mentioned earlier, that the design parameters for the RCC building, I have spelled out everything earlier, that the nonlinear dynamic analysis, you need to have 3 time stress, then carry out the checks for the response spectra, then carry out the jacketing, then analysis and reanalysis, and carry out the checks as table 5 and 6 given in this. So this is how one can create the model in the ETAP or STAT or any other software in which you are comfortable. While doing the retrofitting of the RCC building, as I mentioned, 50% of existing retrofitting works which is happening in our country or worldwide is using FRP jacket, and other 50% is by RC jacketing, section enlargement, or steel plate jacketing. So after conducting the modeling, after concluding that yes, I want to go for either FRP or a section enlargement or this, for that the design procedure is given in 15988. That will be defined based on the deficiency you have. That has to be calculated based on the demand and capacity of each member. So this has to be calculated for member by member, the way it is shown in this particular slide. And that again, it has to be calculated for shear, flexure, bending, moments, and all. So after identification of the deficient members, wherever the DCR is more than 1, do the retrofit, incorporate in the model, redo the analysis, and repeat the process till your building is categorized as a safe category. As I mentioned about the, normally we adopt these peculiar 3 time histories, Chamoli, Dharamshala, or Uttarkashi. Sometimes we can take advantage of Nepal earthquake also 2016 or 2015 because these earthquakes have occurred from Indian perspective of similar acceleration, time window, frequency window, as well as the geotechnical parameters are also more or less same. Or otherwise, if you are not comfortable with, then you can take or rely upon the synthetic time histories also. So for that purpose, one has to generate this thing, and while carrying out the response spectra time history analysis, each response spectrum graph has to be scaled so that the critical criteria of all the ordinates from above period, that is from 0.2t to 1.5t is satisfied, and based on that you have to select the appropriate scale factor and incorporate in our drawing. So this is how we have to scale up the response spectra by making use of different approaches. That is, SRSS is the method which is widely being used for this kind of a study. So this is the view of table 10.7 from AC 41 2013 to pick up the appropriate coefficients for the value of P, M2, M3 for columns and beams. So normally we adopt 0.0034 for the columns and 0.007 for the beams. Again, the number of modes, oscillations, maximum drift has to be calculated, and the mass participation factors up to 65% of all those need to be calculated as given in table 506. After conducting this test, similar to the masonry, we have to do the detailed engineering on drawings also, transfer your observations, recommendations in the drawing format, and this is some of the details in which we are suggesting or recommending the RC jacketing with additional reinforcement again, and how to execute it. That has to be spelled out very clearly in the drawings. This is the picture which shows the strengthening of the foundations in this particular building foundations were found to be deficient, but there were so many isolated footings close to each other. Best way approach is to convert all isolated footings by connecting all together a continuous footing. So this is how you there could not be a single unified procedure for strengthening, retrofitting, or treating any building to make it disaster resilient, but one has to use his own expertise based on the available data. Because I once again would like to mention that retrofitting is not a simple engineering, the way you can design your building a new structure. It is entirely different phenomena, different ball game. It totally depends. You have on the whatever the inputs you are getting from the in situ building. So challenge is reverse, and one has to address it after sufficient experience. So for becoming a retrofit engineer, one need to have a passion first and good experience, and then only after one has to work under some expert for a few days to understand this insights about the retrofitting, then before directly jumping into the field. This after attending the aspects related to the structural members, one has to be very particular about the non-structural members also. For that purpose, NDMA guidelines may be referred to. That section 5.5 clearly defines the acceleration intensity for the non-structural members. So you cannot use the formula given in 1893, but that has to be modified differently as given in this, in terms of FP is equals to Z into 1 plus S X by H bracket complete AP upon RP, IP and WP. PPP are all this similar, all the variables have same notification, that is seismic zone factors, importance factors, then response relation factors, weight and all those things. And basically P is for the acceleration sensitive, for assessing the forces from acceleration sensitive point of view. So one has to, so this is whenever you have a non-structural element related with the mass, you have to conduct the acceleration sensitivity analysis for non-structural element. But whenever the light material which are hanging, like appendages, false ceilings, you have to carry out the non-structural analysis from the displacement criteria or displacement sensitivity consideration. Even your infill walls have been categorized as a non-structural walls, and for that purpose, adequate connections between the non-structural walls to the structural members need to be ensured, the way it has been detailed in this particular drawing. So first of all, you should not promote any construction on the cantilever. If at all it is there, it should be anchored properly to the main structural element. Even your chhajja projection and other parapet walls should be made adequate connections, connected properly to the structural member, the way it is shown in this figure, in the slides. Most of the times, water tanks are placed on the wall, on the buildings. Big hoardings are laid as per the convenience, but it has to be ensured that it is connected to the structural members adequately. So the design procedures is again given in the NDMA guidelines. Here, after designing, you have to calculate the pedestal sizes, how it has to be connected, and that will again depend upon the height of the building and capacity of the water tank. So after this, schools, hospitals, or other facility, the content in the building, mostly in terms of non-structural member furnitures or almirahs, they need to be connected properly, and for that purpose, again, you have to refer the design procedures given in the and it should be adequately connected, and so that there should not be any sliding, overturning, or occur when the floor vibration excessively take place. So normally this almirahs are to be connected as detail in this particular picture properly to the structural members. If it is a load bearing structure, to the wall. If it is RCC frame building, then it is either to the beams or the adjoining columns. So in the end, I can conclude with the saying that enormous efforts, emphasis has been given so far in past 3 to 4 decades on automation, quality, innovation. We have succeeded to a large extent, but not fully. And now it is a time to integrate all these parameters, automation, quality, innovations, along with the safety for the new construction, as well as for the existing infrastructure. For that purpose, we need to take interest in our research, invest in our research, find out the new understanding, find out the new economical solution, and based on that, we need to, again, as a faculty, we need to increase not only simple intelligent boy and scoring 95% or 98%. Nowadays, everybody is getting temperature 98 and 99. Now, percentages also, but one has to see that the technical competency of the engineer has been achieved properly when he pass out from the institutions and go to the field. The competency is not a simple word. It is basically integrates the attitude, skills, and knowledge. He should have a good attitude towards its work. It should attain a good knowledge. Definitely, it is imparted from the faculty of your like you, and the skills he should. After integrating this, he will develop the passion, and then only the real engineering he will put in the place on the site, from institution level, laboratory level to the land. And with this, I will say that you cannot take a chance of entire world or entire country. Let us begin from your home, from your institution, from your town, district, state, and for the country. So for that purpose, there is a need for leveraging each other's strength and ancient history, know-how, common passion. And with this, if you come across any kind of a difficulty, we are there to help you out. You can call back to us. You can write mail to us. And at the same time, when you all are from academia side, I invite you all to visit CSIR CBRI Roorkee, definitely after this pandemic is over, and you send your students to conduct their dissertation work also, even MTech or BTech. MTech we normally take for 6 months, and BTech for 2 months minimum. Accommodation and other facilities we provide. At the same time, the students get an opportunity to work in an ongoing process, ongoing R&D activities of CBRI, because CBRI has wide range of spectrum in which we are working: earthquake engineering, structural engineering, materials, fire, geotechnical engineering, advanced material, energy efficiency, mechanical, automation, 3D printing, so on and so forth. Interestingly, recently we have come out with the construction technology demonstration park. In that, we have constructed around 10 buildings of similar geometry, and only the superstructure is of by making use of different construction technologies, which are ranging from traditional construction like bamboo housing or stone concrete block, to the prefabricated buildings or 3D concrete buildings, even steel buildings, pre-engineered building, light gauge steel buildings. So there are different type of superstructures we have created, and these buildings simply not have been constructed. But it is available for demonstration purpose, evaluation also, and for creating awareness. Evaluation is very important field, because if we simply construct a building, but it should be acceptable to the society, to the user. Before that, one has to conduct numerous amount of functionality tests, specifically from safety point of view, axial test, lateral load test from earthquake point of view. Then it should be economical, it should be speed, means it should be fast in execution, It should have good aesthetics. It should have good comfort. It should be comfortable from acoustic point of view, noise point of view, RF signal point of view, the thermal comfort point of view, energy efficient point of view. There are so many aspects, and important thing in building is their weakness we come across, or we get a complaint about the leakages and seepages and vegetative growth in the building. So all these things we are evaluating on a full-scale test in this particular construction technology demonstration path on each material, on each technology. And now after this evaluation, these technologies are now available with the researchers, academia, or industry, or to the bureaucrat for effective selection of this technology based on their geoclimatic conditions. So this is a very good platform available. I think I can claim that this is a unique facility what we have generated, I have generated at CBRI, and you all are welcome to visit this, understand this, nominate your students to CBRI, and they will also expose to real world before really entering into the real world. With this brief background and my small presentation, ladies and gentlemen, I once again sincerely thank one and all for your attention, patience, listening, giving me an opportunity to speak to you on this particular topic. And now, if you have any questions, I think floor is open to you to raise your questions. I will also try to learn something out of your questions. Thank you so much. Thank you once again.
Yes, sir. It was really an encouraging session, and I'm sure that all the participants who attended this session must have learned a lot from this presentation and session. Sir, we have a pattern, like we invite questions from the sessions, and we have, I can see we have nearly 7 to 8 questions have been asked from the participants. So with your permission, we'll take one by one of them.
Yes, please, sir.
Yes, sir.
Please.
Yes. Okay, so the first question, sir, is should we model a masonry wall and RCC slab as a thin shell or thick shell in ETABS? So it's regarding modeling of components.
Yeah, it's a very good question. Normally, when you are conducting the linear static analysis, particularly for the masonry buildings, up to 100 mm, it is good job that we 115 mm, it is good job that we should model it as a thin element. But for the higher thickness, it has to be modeled as a thicker element. Because why we need to go for the thicker element? If you conclude that your masonry walls are deficient, and in that case you need to go for a retrofit jacketing. So multi-layer approach you have to adopt. So it is a good practice that you adopt a thick shell modeling in ETABS while modeling the masonry walls. I hope I have answered your question. And then multi-level thick walls as well as multi-layer also, because when you are jacketing, so multiple layer will take place.
Right, sir. Right, sir. Sir, next question we have. Is there any guidelines available for carrying out vulnerability analysis of structures?
Right now, as such, no as particular, but it is available in the piecemeal. One has to take collections of references from here and there and compile at single
source of
one single window system is not there at the moment. It is has to be done. We have to make a reference for numerous references of NDMA guidelines as well as some of the Indian codes. Sometimes we may have to refer the ASC standards also, ASC 41/2013, as I mentioned, for conducting the non-linear dynamic analysis. So there is no single window systems available for the assessment of vulnerability analysis. one has to take a call. We are putting our efforts hard to make a unified guidelines, and hopefully in next couple of years it will be ready with the help of NDMA.
Right. Yes, sir. The another question is for non-linear time history analysis. What are the criteria to select ground motions?
Yeah, perfect, perfect. So whenever you have to select the time history analysis, minimum you need to have 3 time histories. Single time history will not do. So each time history should have 3 components: one vertical, 2 horizontal. Whenever you pick time history, this such component should have a wide range of periods involved in it, ranging from 0.2 t to 1.5 t. Secondly, the whatever the time history you pick up, so you have to be very careful while picking it based on your site requirement, site specific information. If I'm constructing a building sometime somewhere in Uttarakhand, so I will go for the Chamoli, this thing, and Nepal earthquake. I will not much rely on the El Centro, which might have occurred, or where the geotechnical characteristics are entirely different than the my proposed site. So one need to understand the geological conditions also, and according to that it has to be picked up. Important thing is the time and frequency window. Apart from that, if you are not you are not having this known time histories, then you may have to rely on the synthetic time histories, and numerous time histories are available in the Department of Earthquake Engineering and also in the website of the Ministry of Earth Sciences, Government of India. Okay, so you can visit that site. There is a numerous banks, data bank is there. You can pick it up, download the time history, and carry out your analysis.
Right, sir. So I think next question is just related to this only. Is it appropriate to consider the ground motion outside India and then make it compatible to IS response spectrum?
Not an issue. What I said earlier, questions,
Yes.
similar things, but you can pick it. You have to. These are the precautionary measures I have told. There is nobody stops you in picking up the outside India, and because earthquake has no boundary, it will kill you, kill everyone. So
Right,
that is not an issue, but you have to make it compatible to our proposed site and IS. And I have shown you the example of Chamoli earthquake, the Dhamshala earthquake, how we have implemented the scale factor, upgraded it to IS response spectrum.
Right, sir. Okay, sir. So next question is, suppose structural drawings are not available for existing structures, then how to proceed for detailed vulnerability study and retrofitting strategy?
Very good questions. Suppose word should not come, it is always there. You will not be available structural drawing, first of all. And I think entire my presentation was highlighting that aspect only, that how to create the drawings. You have to go one to one you have to create. For geometrical drawings, as-built drawings you need to generate, recreate, and thereafter conduct the extensive NDT. Then only you can do the detailed vulnerability assessment. And apart from that, you have to conduct the rebar locator. You have to implement the rebar locator to identify the reinforcement spacing, diameter, detailing. Then only you will come to know what kind of reinforcement has gone into to calculate the capacity. So your job is enormously increased, substantially increased, if in absence of these details.
Right. So one has to perform with its best capacity to develop these drawings. Yes.
Sure.
Yeah. Sir, another question. For performing a non-linear analysis in SEP 2000, how to input? Yes. Yeah, and for performing a non-linear analysis in SEP 2000, how to input existing longitudinal and shear reinforcement, particularly in beams?
No. I think that micro level detailing you need not have to do for the in the SAP modeling.
Mhm.
If you do that, because it will give you the AST, and from that you can calculate. If you go to that, your computational time and other things will increase. So that
Mhm.
is sufficiently fairly good embedment enforcement you can do in the any FE software, and carry out the detailing work on a component level. But on a system level, if you carry out, this will be a really a this R&D thesis project.
Right, right. Okay, sir. Sir, another question. Can we take default hinges as per the
Yes.
FEMA 356 or ASCE, or we need to define hinges from moment curvature for individual members?
No, no, you can take it from FEMA 356 or ASC 41, and along with the appropriate coefficients as given in the table 7.10 of ASC 41. So coefficients value you have to not to take from the software defined, but you have to pick it up appropriately from the table.
Right, sir. Uh, sir, another question we have. Can we recommend or rely on the durability test for deciding the retrofitting strategy?
I think question is not clear to me. Durability tests. So
Okay.
basically, these are again qualitative. No, I agree. But these are most of the durability tests are qualitatively. One has to
Mhm.
take a call based on case to case basis.
Right, sir. Another question, sir. How can we perform analysis using software that the deficient strength of the existing building will be recovered or overcome by the methods to be provided as retrofitting measure?
Demand capacity ratio you have to calculate. Demand is the things which has been imposed by the earthquake or codal defined provisions on your structural members, in which you are clearly defining the geometry and material properties. Once you know the demand, and if you find the deficiency in that particular building, definitely you have the cutoff permissible stresses or provisions or criteria given in the code. If these are, so that's how you can identify the deficient members, and such deficient members you will going to strengthen. Suppose you are conducting the RC jacketing and section enlargement. So for that purpose, retrofit, you have to calculate the how much amount of deficiency in terms of the force level and capacity level you are having, and as then refer IS 15988. In that, it gives you how to calculate the how to design for the balance capacity and strengthen it. Alternatively, in the model, you have to increase the sectional dimension and carry out the analysis. You know the existing reinforcement, how much it has been provided, and from the analysis, you will come to know what is the demand is there, and the difference you have to calculate with certain, and then this is how you have to go by element level.
Right, sir. And sir, last question we have, which structure will be more vulnerable to seismic excitation, one constructed on hard soil or the other on the soft soil?
Definitely, hard soil will be less affected than soft one, because in the soft soil your amplification will be higher. And again, in the soft soil, when it is coupled with the high water table, liquefaction possibility, and sandy soil and all, so liquefaction potential is also increased. So definitely hard will be much better than this. But again, this cannot be taken on a prescriptive basis. It will depend upon the fundamental frequency of your proposed structure. So there are so many parameters, single parameter cannot, but definitely soft soil will be vulnerable.
Right, right, sir. So I think, sir, on behalf of all the participants, I would again express our sincere gratitude to you, and you just beautifully answered all the questions. So I think all the participants must have got their problems solved by and large. And we are also thankful to you for inviting our students and participants at Roorkee for future prospective projects. And on behalf of Atal Academy, on behalf of Marwadi University and Department of Civil Engineering, we all are very thankful to you for sharing and sparing your time with us and delivering such a fantastic, knowledgeable session to all of us. So once again, sir, with this note, we'll thank you for being with us. And we are, this is just a beginning, as I said in the beginning. So we'll be definitely be in touch with your support and from CSRI and CRIB. So definitely we'll work together in future also, sir.
Thank you so much. Thank you. Thank you once again.
Namaskar, sir.
Namaskar.
Thank you,
Have a
sir.
safe stay. Thank you.
Thank you, sir.